So may I request Professor Haridas to please take over? Thank you so much.
Good afternoon. Welcome to the Reminiscences session now. We have heard a lot of talk which has reflected on Professor Mitra's science side. And now in this session, we also hope to hear more about the human being that Professor Mitra was. Of course, these two aspects are inseparable. So let's move on to the Reminiscences session. So each speaker is allowed 15 minutes altogether, and of which 12 will be your main presentation and 3 minutes for an audience interaction. So after 10 minutes of your talk, I'll alert you to finish your talk in 2 more minutes so that the 3 minutes will be available for, audience participation. So with that, I invite Kalyan Sinha to be the first speaker in this session.
Good afternoon. Can you hear me?
Yes.
Okay. So I begin by thanking the organizers, particularly Professor Mishra, for taking the initiative to make this happen. And I will briefly describe, let's say, 4 periods of an encounter with Professor Asoke Mitra. First, of course, when I was a student in Delhi University Physics Department, that was the period 63 to 65. He taught us in both years, I think. In the first year, he taught us electromagnetic theory, and the second year, quantum field theory. He was a very good teacher, very meticulous, particularly while doing detailed calculations. Some of them were very long. And I enjoyed the classes. And in fact, so much so that in the so-called MSc thesis or dissertation in the second year, I chose to work with him on a 3-body problem dissertation, which we did. And some of his PhD scholars at that time, of course, PhD was something far away, and we used to wonder what these guys were doing. And particularly, I remember Balram Singh Bhakkar, with whom we used to interact quite a bit. He was senior to us, and we used to often run into him in the department late at night sometimes, and used to have a good interaction with him. He was one of the senior students of Professor Asoke Mitra. Then in the lighter vein, an incident happened, which I would recall. One of those days, I think some of us were taking a walk.
Professor Sinha, could you please adjust your camera so that you're visible to the
Yeah,
audience?
I recognize that, but unfortunately, I don't know how to do it exactly.
Okay. Please go on.
Let me see.
Yeah.
Okay, I find something called video setting. And then I think Professor Mishra, if you can guide me a little bit, what should I do?
Well, my 1 paisa worth of so-called advice is that, are you speaking from a desktop or a laptop? First off.
Desktop.
So, I see. Do you have an inbuilt camera, or is it an attachment?
No, it is an inbuilt camera.
Oh, then maybe you could push your chair a little bit. Just push.
Okay, okay. I'm trying that. Maybe I can go back.
Or maybe put a cushion on your chair.
Yeah.
That will be rather difficult to do at this juncture. So I think that we will manage with that. Maybe I'm barely visible.
Yeah, we can at least see a little bit more of you.
Okay. So shall I carry on?
Maybe you could push a little bit more. You're almost there. You're almost there.
Well, I'll have to straighten up a bit.
Okay, please go ahead.
Sorry. On my part. Okay, I think a little more of me is visible now, I guess. Shall I carry on?
Yes,
Yeah, please.
sorry.
Okay, so up in the hill, Flagstaff Hill, we were taking a walk, and we found Professor Mitra struggling with his car up there. And so all of us, we gladly put our shoulders to his car and to perform a high energy experiment up there and to help start the car successfully, and shared some of the lighter moments with Professor Mitra at that time. Then, after a gap of over a decade, I met him unexpectedly in São Paulo, in Brazil, where I was visiting briefly from Geneva, Switzerland. And then I was quite surprised, and I took him around to show a little bit of the city of São Paulo, particularly near the university, and then brought him home for a meal together. So that was the second encounter with Professor Asoke Mitra. And the third one happened when I returned to India. And as it happened, I had gravitated away from physics and more into mathematics over the years. And I was in the editorial board of the Mathematics Journal of the Indian Academy of Science. And I thought, along with some of my colleagues, we thought that there is not enough good work in mathematics in India to deserve so many journals. So we wanted to consider the possibility of combining some of the journals into making one or two good journals. And the opportunity came during the annual meeting of the Academy in Pune, that is 1980 I'm talking of. And Professor Mitra was there in that meeting. And he was at that time the editor or editor-in-chief of the INSA Journal of Mathematics, named, I think it is called Indian Journal of Pure and Applied Mathematics. So I cornered him and sort of started the discussion about this proposal of mine, which was, of course, a bit preposterous. I realized later so we had a long, serious discussion on it, but unfortunately, this didn't go too far. And then the last encounter that I will mention was several years later, when I had just moved to Bangalore, and I suddenly got a call from him. There was a surprise to me, inviting me to contribute an article as was referred to by Professor Lakshmanan, Professor Panchapakeshan, and Professor Ramakrishnan earlier in this very large volume that he was trying to gather articles in. And he wanted me to yes. Yes. Shall I continue?
Yeah, please do.
And I did contribute a short article on non-commutative stochastic processes, and in the development of which I had some role to play in my stay in Indian Statistical Institute. And that was the last time I interacted with him. And that journal, that volume came out as Professor Ramakrishnan was talking about. It was a rather large volume. So summing up, in my long academic journey, I shall certainly count Professor Asoke Mitra as one of very few who had invigorated me and propelled me forward and farther. And I take this opportunity to pay my homage to him. Thank you.
Are you done? Hello?
I finished. I said thank you.
Yeah, thank you very much. Now, the floor is open for the audience to interact with the speaker for 3 more minutes. Any comments, questions? If not, let's thank Professor Kalyan Sinha for his wonderful reminiscence. And our next speaker is Amitava Raychaudhuri. Professor Raychaudhuri, can you start?
Yes, I can. Is it possible to project my slides from Alok's place? Or I can try to project myself, but since time is at a premium, I hesitate to struggle with that.
Alok?
Yeah, sure. Just give me just 15 seconds, please.
Okay.
Yeah.
To begin with, you know, what I say in this summary, my reminiscence about Professor Mitra, it actually is what I think any one of 10 of our class friends. Yes, thank you. Thank you. This is the first slide. Can I go to the next slide, please? Yes, thank you. So what happened was that about 10 of us from Presidency College who had a very difficult time in our undergraduate days collectively moved to Delhi University. And we had heard of Professor A.N. Mitra and S.N. Biswas and various other people at Delhi University. And we were very moved to, we decided to move to Delhi together. So 10 of us, roughly 10 of us moved, and we were mesmerized by Professor Mitra's and others' teachings at Delhi University. Now, you know, when I look at the list of the talks in this conference, it is mainly particle physics and field theory, while there is some nonlinear dynamics and coordinates matter physics also. But I should say that, for example, Professor Mitra was a keen physics motivator, and he had motivated all 10 of us to continue in physics, and all of us have continued in physics, but not all in particle physics. In fact, I'm the only one in particle physics amongst our group, and the rest, they have all gone to do their PhDs in various places, and they have settled down. Their condensed matter physicists, theoretical as well as experimental, and the nuclear physics, and so on and so forth. Professor Mitra, he was a very, very strong motivator. He convinced us that we must do physics in our career, but he was not a narrow person. He never urged us to follow in one direction. Now, we also had heard a lot about Professor Mitra as a researcher. We had heard that he was an extremely good researcher in both nuclear physics and particle physics. And we were very keen to have him as a teacher. And in fact, he taught us quantum mechanics 3 in Delhi University. In those days, there were 4 parts of quantum mechanics, and quantum mechanics 3 was relativistic quantum mechanics, and quantum mechanics 4 was QED. And Professor Mitra taught both of those courses to our section. The sections were started in our year, and so there are 4 sections, and to our section, Professor Mitra was the teacher for these 2 courses. Now, it is possible that Professor Mitra prepared for his class lectures very meticulously. It is possible, but it was never apparent. When he came to class, he just started from very basic ideas, and then gradually he would fill up the blackboard with calculations. And in the end, when the final result arrived, then he seemed to be as surprised as we were all in the class. So he used to clap his hands or shake his fist or whatever, and as if he himself was surprised that the actual good result, the final result, could be obtained. Now, what it taught us, I find later on, is that it taught us to calculate, how to do a calculation starting from scratch, and to keep on struggling with it and eventually arriving at the end result. Now, this is the part about our teaching. Then it turned out that Haridas had the fortune of working with Professor Mitra for his MSc thesis. In my case, I did my MSc thesis, MSc project with Professor Kamal Datta. Now, Kamal Datta had suggested to me that I should work on, can I go to the next slide, please? The next slide. Yeah. So I was asked to work with Professor Kamal Datta, and he suggested that I work on the Goldstone boson and symmetry breaking. Now, that was a relatively recent thing at that point of time. And I struggled with a few papers, and I found it very difficult. In fact, that was my first experience of reading a published paper. So it was quite tough. I must say, Professor Datta had helped me quite a bit, but even then, I don't think I made much progress. But I wrote up some project report and submitted it. Now, I don't know how the examiner was chosen, but it so happened that Professor A.N. Mitra was chosen as my viva voce examiner, which scared me stiff, because we knew how knowledgeable Professor Mitra was in these subjects. So the viva voce took place in his office with Professor Kamal Datta also present. And he, Professor Datta, I don't think even asked any question at all. It was only Professor Mitra. And then Professor Mitra asked me, he was very kind, but he asked me very deep questions about spontaneous symmetry breaking. And I must say that at that time, I knew very little about it, and whatever I knew was very cursory. So I attempted to answer his queries. And I must say he was very generous, and he gave me a good grade. As always, he was always a very generous person, and he gave a good grade. Later on in life too, I had some contacts with, yes, thank you. Later in life, I also had contacts with Professor Mitra. We knew that he had made very fundamental contributions to the three-body problem, and he was regarded as an authority on the quark model. We knew all of that, but we hardly knew his stature in the broad area of particle physics until we started research. And then we came to know how highly he was regarded everywhere in the international community. Now, after my doctoral studies abroad, I decided to return to India. And at that time, it was a very difficult decision for me, and I didn't know whether I was doing the right thing. So when I next met Professor Mitra, which was quite very soon after returning to India, when I met Professor Mitra, he was highly supportive. He said that I had done a very good thing. And in fact, he supported that I had chosen to be at Calcutta University. He was very supportive of that. And I immediately knew that I had made the right choice. There was no doubt in my mind after that. And I had the fortune to meet him many times later at Delhi University and also in meetings and so on. And he followed my career, I think, with he always followed what I was doing, what problem I was handling, and so on. And I was always very happy with that. I also believe that he was happy that I had chosen to be at the Harishchandra Research Institute for some time in between. Now, I then share with you a few correspondences which I could dig out from my emails. Can I go to the next slide, please? So after I returned from the Harishchandra Research Institute in 2011, I sent a letter to my friends and acquaintances that I had moved, and then this was the reply which I got within a few days from Professor Mitra. Dear Amitava, congrats. This looks like the right place for you. Inasmuch as a Palit professorship in any day is any day a higher position than the directorship of an institute. Of course, now this is the last line, which was very difficult to decipher. Of course, my, within quotes, claims on your success continues unabated, and they will take many forms at different times. Now, I think it is best left to interpretation. Anyway, I interpret it in one way, and then best regards, A&M. That's how he signed all the emails. Then,
Professor Raychaudhuri, could you finish in 2 more minutes?
Yes, I will.
Yeah.
At the time that I joined Calcutta University, very soon after that, Professor Mitra told me that there was a scholarship given to the students standing first in mathematics or physics at Calcutta University, and somehow not much information was available about it. So he wrote to me after I came back again from HRI. He had already made me the representative on his behalf. And then he wrote to me again saying, why was this scholarship not being given and so on. And you can read for yourself what he has written. And he wanted to find out what had happened to the scholarship. So I replied to him immediately. Now, he wrote at 5:10 a.m. Now, that the other mail, the previous mail was written at 11 p.m. So obviously he worked very hard. And now let's go to the next slide. So I wrote to him immediately that, I will check and find out. So I get up much later. So my reply was at 8:50 a.m. And then I wrote later, next slide, please. I wrote later, the same day, in fact, but in the evening, that I have checked with the university and that the Professor Nath Mitra Scholarship is being granted to students from the departments of Applied Mathematics, Mathematics and Physics by rotation. I have asked them to send to you and me the names of the recipients of the scholarship in the last 4 years, which they did, in fact. And this scholarship is still being given. Can I have the final slide? Yes, please. So in the end, I consider Professor Asoke Nath Mitra as an ideal example of an academic. That is, he was not only a very good teacher and also a very good researcher, but he was really a role model for his students. And that is, I think, the most important thing. He kept track of how his ex-students were developing in later life and continued to help them in their career path. I have been benefited by his advice many, many times. I learned from him physics and much, much more. Thank you very much.
Thank you, Amitava. Now the floor is open for the audience interaction. We have 3 minutes for that. Any questions, comments? If not, let us thank Professor Raychaudhuri once again
Thank you.
for his very spirited reminiscence of Professor Mitra. And our next speaker is Professor Dilip Choudhury, a very close friend of mine, and I call upon him to make his presentation. Dilip? Dilip? Yeah.
Okay. All right.
Yeah, please go ahead.
Yeah. Yeah, my daughter here. Yeah. All right. Is that all right? And you all right?
Yeah, we can hear you.
All right. Okay. So, so I'm very happy to be here and with our friend Andy Haridas. In fact, I'm a former student of Professor Kalyan Mitra, most dearly called Asoke Nath. Inspired by him, I spent mostly 50 years in physics of cost and growth, and recently published in the book 50 years of cost and growth, edited by my student Gargi Choudhury and is dedicated to my respected Asoke Nath. So 60 years ago, in 1965, I came to the Delhi University and joined MSc course. There, I came across my mentor, Professor Nath Mitra, now mostly taught by Asoke Nath. During 1965-67, he taught us quantum field theory, and Professor and my friend Andy Haridas and Deepak Kumar was also there. Yeah.
Can't hear you, Dilip.
Okay. All right.
Yeah.
So during 1965-67, he taught us quantum field theory, and my friend Andy Haridas and Deepak Kumar were also on. I mean, two of them. I think they will remember. So I wrote a thesis for MSc dissertation on group theory under his supervision, and 1967 was a crucial year because I have completed my MSc and thought of doing physics research. And in the meantime, my friend Andy Haridas left for USA, and so to Deepak Kumar. So I mean, taking suggestion of many friends, including Jagannath Ross. So they told that Professor Mitra would be my right choice of guide. So I approached him and told him that I am to do PhD under his supervision. He quickly agreed, and he told that that the best thing is to that if you do some work research on the cork model. The cork model was just proposed by Gell-Mann and 2 years back in 1964. So I started my journey into physics, entering the Kalpa and spending many hours there, and 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 I started my research under his supervision. So I think in 65 or so, he was abroad, and he did some work with a physicist named Mark Ross on some recoil and scattering effects of baryons using cork model. So he has asked me to apply these things to mesons, and he gave many of his calculations so that I can do it promptly. So in fact, in a short period, I wrote a paper called Recoil and Scattering Effect in a Strong Decay of High Iron Meson and published in Physical Review D in 1960, 6 or so. So that was my journey into physics, inspired by Professor Mitra. And then he asked his former student, Professor Dilip K, to collaborate with me. So things were very quick. So Bijugara helped me immensely. So shortly we published 3 more papers on meson baryon scattering using a 3-body model called QQ bar model proposed by Mitra. So we published 3 more papers. So total 4 papers are published in Physical Review D, and submitted a thesis. It was named the decade of mesons in cork model, and published and I got PhD in I think around 1969 or so. So then I got a postdoctoral fellowship from CSR, and I again approached our respected star to guide me and join his group. So we worked together on trying to study the effect of higher baryons in the neutron-proton mass difference, and which we published in Physics that was big. And then my luck came. I applied for some fellowship abroad, and the Royal Commission for Exhibition at London gave me 3 years fellowship to choose a place and a guide. So my question is, where to go and who will be my guide? I approached Asoke Nath what to do now. So those days there are 2 great persons in UK. One is Dadi at Oxford and Abdul Salam in Imperial College. So I could choose either of them, but Professor Mitra, I must go to Dadi. He's the expert requirement. So at the suggestion of Professor Mitra, I went to Dadi's, and I got a 3-year fellowship, and Professor Mitra suggested that your name at the supervisor. So after some days, so he agreed that he is very busy, but still he welcomed me. So I spent that 3 years there, and my friend Andy Haridas and Deepak Kumar were also there sometimes. He got me. I'm really fortunate enough to do them, and I really remember my another friend, Deepak Kumar. So those 3 years, I have collaborated with various species from abroad, somebody from USA, UK, Pakistan, and all those things, and published several papers in Physical Review D and Physical Review. It's basically on pattern model and dialectical Kalyan algebra. So with all this, but doing all these things, Professor Mitra, when I left for UK, he told me, number one, don't be overexcited over other people's ideas unless your ideas fit. Number one. And number two, don't become panicky because of course it's very different from Delhi. So you try to collaborate with some business whom you like. So I think I overall his birthday advice. I can many friends on now medical Robert Barney from USA, T.S. Tan from China, Carl Schulzer from Germany, and Henry from Belgium, etc. So we published several papers. And then for 3 years of stay, I returned to India. Of course, that time job was not easy to get, and I could not manage a job at the Delhi or there. So I came back to my hometown and I started my new journey as a research guide and collaborator. I started a research group at Guwahati University, but I continued my interest in correction, and 30 students already got PhD under my student, and there are some of them are already retired, some of them are still professors. So in that way, I consider myself a way modestly successful thesis, but not as great thesis as my friend Andy Haridas, who was brought up and a lot of people higher than me. Okay, Andy. So with my modest background, I think I tried my best to continue my journey inspired by Asoke Nath. And I still remember him. He told me, you are doing good work. Why you are depressed? So I still continue that I have done some work in my humble way and contributed something to my society. 30 students, I got PhDs. They are also getting research. They are producing PhD. So
Dilip, can you finish in 2 minutes?
Yeah, I'm finishing. So in that way, I think I have fulfilled what Asoke Nath told me, and
sure.
and following him, I asked my students when I meet them even now, tell me what you are doing on. Okay, so that's the program of Asoke Nath. I still continue when I go to my workplace, go to university. I asked my students what they are doing. So they always tell me what they are doing. I don't gossip. I don't talk physics. Even now I continue some physics. I've got a health problem sometime from last year, but still I hope to continue physics as far as possible. Thank you, and thank you, Andy. Okay.
Wonderful. Thank you, Dilip. Now we are open for audience interaction. We have 3 minutes for the audience to interact with Dilip. I think the audience is overwhelmed by the reminiscences.
Okay.
So if there are no questions or comments, we will pass on to our next speaker, Professor Wasi Haidar. I don't see him anywhere. Professor Haidar, are you here? Alok?
Yeah, actually, I've been, I don't know, I think Professor Satendra Sharma said that he had sent him a gentle reminder. I don't know. I mean, I have zero idea. I don't know. I don't see him.
So should we go on to the next speaker?
I would probably, yeah, I would say that maybe we could do that. And if he
Okay.
joins, then he could be
Fine.
asked to
If he
speak.
comes later, he can always join.
Exactly, exactly.
Yeah, sure. So I call upon Professor R.S. Kaushal to make his presentation. Professor Kaushal? Yes.
I'm here. सभी इस सभा से जुड़े हुए अतिथियों को मेरा प्रणाम. Very good evening to everybody. And actually, in Hindu mythology, there is a mention of Lord Dattatreya, who had 24 teachers in his life. And but I have only 4, and Professor Mitra is one of them. I have very high regards for him. With your permission, can I recite a sloka in his honor?
Please go ahead. You are a speaker. And
Gurur Brahma, Gurur Vishnu, Gurur Devo Maheshwara, Gurur Sakshat Param Brahma, Tasmai Sri Guruve Namah. He was much more than a teacher for me. I learned from him in all the 3 fronts, namely physics, mathematics, and spirituality. Can I have first slide, Professor Alok?
Yes, please. Just give me 15 seconds, please. Just, yeah.
Better to read because shortage of time, I cannot go and speak unnecessarily. Please. Is it visible or can you enlarge it a little bit if possible? Anyway, I can manage from my stuff. Professor
Yeah.
Mitra has
Full
been a
screen now.
source.
It's full screen
Yeah.
now.
Yeah, okay. Professor Mitra has been a source of inspiration for me all throughout my life on all the 3 fronts, physics, mathematics, and spirituality. This inspiration have been in both visible and invisible form. I have been a club student of Professor Mitra. Professor Mitra had liking for the Vedanta philosophy. In the morning, Professor Panchpakesan has already confirmed it. He had liking, he had a good sense of humanity, or very well, difficult to use words for him on this aspect. Professor Mitra wrote foreword of my first book on Vedanta philosophy, which I wrote in 1994. In fact, this small research paper was published in the CSR Journal of Scientific and Medical Research, which I enhanced in the form of a book of about 125 pages. And Professor Mitra kept it for a week or 2 and came out with a 5-7 pages preface for that book, which proved to be a source of inspiration for me for my further work in Vedic science. It was 1994. Now, even today, after 30 years or so, I am using the same proposed patomic model, patomic philosophical atom type model, which is based on the wisdom from Upanishad and Srimad Bhagavad Gita, with the reference to a functional human being, not the dead human being. In particular, attempts have been there to understand human behavior and experiences. Experiences is subjective, behavior is objective, we can say to some extent, using some analogies borrowed from physical sciences and theories as well. To this effect, I wish to quote the concluding paragraph of Professor Mitra's article published in Current Science in 1993. Title is Profiles of Scientific Philosophy and Paradigms and Serendipity. The poetic conclusion he has given is in the following form. I'm dancing with my ego face. I'm a particle, my ego a wave. Perhaps he wanted to give example in the classroom with regard to the wave-particle duality. And perhaps, I think in that spirit, he has coined this phrase. And during last 2 weeks or so, since I decided to present my things, I thought over it. So let us see. Dancing with my ego face. Ego is in the background of all human beings. It's the ego which makes us sensible, workable, whatever you want to add it. And dancing is something which only a living human being can do it. So Professor Mitra perhaps thought the particle inanimate. I'm dancing with my ego face. I'm a particle, my ego a wave. So let me make this particle living being. Then how things change. Can I have next slide, please? Professor Alok? Yeah. From atom to Atma. My PhD thesis in IIT Kanpur was in atomic nucleus, nuclear energy physics, high energy physics perhaps. Understanding nucleus structure through elementary particles. Exploring a model for human consciousness. This 21st century is going to be the century for consciousness studies. And how to understand it? I have used the Vedic wisdom in this context to give a scientific flavor to the Vedanta philosophy. And I don't know to what extent I have been successful, but I feel satisfied. Whatever little I knew, I learned physics during the last 3-4 decades. I could apply some of these ideas in my own style. So I shall come back to this transparency later if time permits. Let me describe the model. What is that model? Very simple-minded model based on the wisdom of Srimad Bhagavad Gita. Next slide, please. Yeah, here it is. So philosophical atom type model. 4 books I have written, about 1200 pages, another a dozen articles in psychology and in philosophical journals, based on the famous verses from Srimad Bhagavad Gita. I have quoted them. These are, if you want, I can narrate them also. Symbols. See, they are undeniable facts of human life. What are those undeniable facts? Look at the picture. We have worldly objects. If we start how to use it. Yeah. See, in the center, we have worldly objects. I have defined here. WO is the worldly objects and stimuli like physical world, wealth, power, and fame. B is the biological body consisting of physiology and anatomy. Nothing beyond that. M is the mind, I intellect, E is the ego. Please, I'm explaining the symbols, unusual symbols, but they are consistent for the last 30 years. No change is there. Then here, chitta, in Antachatushta people call it, so that is merged into the dressing rules actually. Innermost existence is the soul here. So in atomic physics, we have a outermost valence electrons, which start interacting earlier, but here it is the other way around. Inner part interacts first and outer part later. And they are classified actually, all these essences of life, they are classified in 3 categories: gross existence, micro existence, and causal existence. Once we have 3 kind of combination, which are very common in the Vedanta philosophy, many things can be explained on this basis. So then B is the capsule of everything, contains SO as well as W, and it performs the transition upward and downward. Upward transitions are rare, as it goes with the yogi category of persons. Downward transitions are there with the worldly persons. Next, transparency. Well, so this model, psychophysics, very badly used, And next transparency. Yeah. I have compiled 4 books, starting with the one cited by Professor Panchpaksh in the morning. Second one is Prakriti and Purus, title is Theory of Fundamental Process in Human Behavior Experience. I think I borrowed the skill from Feynman diagrams here. Then another one is the Psychophysics and Human Interactions. And this is the latest one of 20 last year's publication. And a lot of mathematics, analytical things are there. So this was the one aspect inspired by Professor Mitra by writing the foreword of that 125-page book. And the place where I was inspired by him, in 1991, I wrote a paper on quantum mechanics of non-central potentials. I think this is one of the most cited paper of mine today. And here I solved the Schrodinger equation for 2-dimensional non-central potentials. Non-centrality, non-separability, they are defined in a strict mathematical sense. Normally, you know that in physics we deal with one-dimensional systems or radial direction of radial coordinate of 3-dimensional system. So ultimately, problem reduces to 1 dimension. So non-centrality does not arise so frequently without arise with the spherical harmonics. If interactions are spherical, tensor forces are there. So exact solution obtained. So I wrote a paper, it was published in Annals of Physics. I gave a copy to Professor Mitra to seek his observations on that paper. He kept it for 2 months on his desk, and whenever I see him, oh, I'm looking at your paper. It looks very interesting. It looks very, so that was another encouragement. It was 91. Then I started looking into the non-central forces, integrability in the classical mechanics sense, quantum solvability in the quantum sense, and I found an exact solution, a variety of non-central potential solutions. And regarding classical mechanics, we also worked with other PhD students, and we are about 2-3 dozen papers on the subject.
Professor Kaushal, could you finish in 2 more minutes?
Yeah, I can do. Even now I can stop. So that was the idea. So I don't want to come. Well, can I go to the transparency too? The process. Hello? Can we go back to the previous transparency? Anyway, so what I have done actually, I have suggested next one. Contents are here of the book. Major contents I have developed: psychophysics, psychochemistry, human relations can be understood. Exactly in analogy with the atomic chemistry, we have done a lot. Work has appeared already in psychological journals. One can talk about what are the 2 good friends or bad friends, 3-body problem, 4-body problem. And not only that, in the classroom, we can judge how much percentage your lecture has been understood by the students. Or principle of minimum effort. We talk the principle of least action in physics. But remember, in human being always makes a minimum efforts principle. Here I have included the meditation variable, extremize the things in the calculus of variation speed, derive the psychodynamical equations, solve them, and I have proved them. See, when you drive a car in a crowded lane, you get all the 3 parameters: space, time, and consciousness on the same footing. How to account for the consciousness? Consciousness we normally neglect in all physical theory as a assumption or the model or as a shortcut to solve the problem. In quantum mechanics, the wave function collapses in the consciousness. This statement was made by Professor Panchpaksh. The point is that wave function collapses in the wave consciousness because Schrodinger did not know how to account for the consciousness. This model gives a guidance to account for the consciousness. So, principal minimum of efforts, equation is solved. I have
Professor
shown that
Kaushal, you should stop in 1 more minute.
I stop here.
Thank you very much. The floor is open for audience interaction for 3 minutes. If there are no comments and questions, we pass on to the last. Yes, Professor
Yes.
Satyendra Sharma. Yeah.
Thank you, sir. The presentation of Professor Kaushal is very informative and new ideas there. I have to ask one thing that he's showing 3 transitions from the being or jiva, B, small b. One for SE, which is the sense of knowledge, and B for the biological body, and W. So, sir, please can you tell us about, whenever there is transition, we have the energy intensity of the transition. So any information?
Actually, Rama, you are still imagining. These entities, they exist in the meditation space. See, when you sit in meditation, first thing comes the worldly objects. Then you try to concentrate, try to control your mind, your intellect, and later on at a much deeper level, the ego concept. Once you overcome the ego, then you merge with the cosmic consciousness, part of the cosmic consciousness, that is soul. So downward transitions are more favorable. Everybody, each of us want to have a stomach full. See, we have to live in this world. It's natural. Everybody is starting from labor to the intellectual even. We are running after our stomach, right? So downward transition more favorable, upward transitions are rare. Rare means you have to concentrate, you have to devote. So you have attention carrying processes. So meditation is one of the process where you carry the attention. Attention means consciousness is always there. I have given empirical formula for the meditation also. If you wish, I can narrate, but everything is there in the book. Kindly look into this recent book, 24 publication, published by this DK Print World. He doesn't accept ordinary write-ups. Please.
Thank you.
There are a lot of problems for younger generation.
I'm afraid we have to stop here and go to the next speaker. I'm sorry to interrupt, but time is of essence for us. Thank you very much for your participation. And we move on to Gargi Mitra, the last speaker in this session.
So, Professor Haridas, with your permission, I need to share a video prepared by...
Absolutely. Please go ahead.
Okay, thank you. Thank you.
Where is the video? Alok?
Alok, you have muted.
Yeah, just give me 15 seconds, please. Sorry.
No problem. So I would like to make an announcement after Gargi Mitra's talk. It is requested that as long as you don't feel uncomfortable about it, please turn on the camera so that we can take a group photo or a screenshot, as a remembrance of this wonderful meeting. Thank you.
If my parents were around today, then for sure they would have been absolutely overwhelmed by your love. In fact, I don't know how to express my gratitude. Only my heartfelt love to all of you. My father always used to say that his father, Professor J.N. Mitra, was his first teacher. Now, they were both very humble. I've heard that once Feynman was hosting his talk, and my father started by apologizing for something he thought was lacking in his presentation. And it seems Feynman pulled him up, saying something like, "Oh, come on, shed your modesty and give a good talk." So even Feynman must have noticed how humble he was. Personally, I received much love from Uncle Mishra. And today it's his birthday, and I'm dedicating this talk to his memory. So if we look at life's evolution, that is at the 4 billion-year-old tree of life, then living systems can be viewed as boundary conditions that constrain the incoming flows of matter and energy, and which in turn sustain them. Now, because of their environment responsive nature, sometimes new materials can form by chance, plus the phenomena of self-organization can cause the formation of new complex modules of interacting molecules, and then functional takeovers by newly formed materials and or new complex modules can lead to altered boundary conditions, which for each iteration is subject to natural selection. In the traditional picture, if you can assume the abiotic formation, selection, and confinement of simple organic building blocks, then self-organization could cause the formation of autocatalytic networks, and then whose complexity would be expected to increase in time. Considering the material-independent picture, Kalyan Sinha suggested that environment-responsive crystal ancestors could explain the formation and parasitic takeover of mineral hosts by new organic materials. Mitra invoked a computing soft magnetic jacket comprising 2 ingredients, magnetic colloids and H fields, to address the same assumptions. Now, there were issues with the crystal ancestor scenario which can be circumvented via the field-induced structures. For example, the principle of continuity is respected since magnetic structures and mechanisms are universally present across biology. Again, the electric dipolar nature of biocolloids makes them responsive to intracellular electric fields. And as pointed out by Levin, in fact, many properties of biological systems are present in the physics of electromagnetic fields. Such kind of morphogenetic information, endogenous electric fields, pH and ion gradients, and plus mineral-like biomodules that are associated with living systems can be readily found in astrobiological locations, though information in the form of DNA codes cannot. And Nishke et al. Have suggested that mineral colloids could have served as E-field responsive matter. Now, it is important to note that field-induced assembly is akin to biological self-organization, where information flows both ways. And as very elegantly expressed by Al-Harak et al., electromagnetic fields morph the interaction energy landscape of particles that are susceptible to polarization. Therefore, field-induced structures readily satisfy the requirement of 2 explicit levels with feedback, which is necessary for the adaptation, evolution of complex systems. And this criterion is not satisfied in Kalyan Sinha's crystal hypothesis. The first ingredient we require is an external field, say in the form of magnetic rocks. This can be expected to be heterogeneous and arbitrary in nature. The intensity could vary, the direction of the field can vary. And the other ingredient is magnetic colloids, especially consider Brownian rotation, where the entire fluid dispersed particle rotates. Now, the search for magnetic colloids led us to Michael Russell's Mount scenario, where colloidal minerals like greigite form in the precipitating barriers. And this FES mineral bears resemblance to catalytic clusters in ancient enzymes. And Mitra was looking at its magnetic phase for field-induced structure formation. Sure enough, rhomboids form in the chimneys in the Mount scenario. And using the Wilkin-Barnes model for magnetic rhomboid formation, Mitra worked out the feasibility of nanoscale aggregates, that is, if the external field can be jacked up to about tens of millitesla. To mimic the cell medium, we also suggested using mineral liquid crystal phases as for example reported by workers like Patrick Davidson. This is since mineral colloids can exhibit shape anisotropy, like rods and disks. So the idea is to enhance the susceptibility of the phases by including magnetic impurities, as for example has been demonstrated by Constantin and Davidson, although they used an organic matrix, but the same principle should apply. And as expressed by Constantin and Davidson, field control phases have the inherent potential to facilitate transmission, processing, and storage of matter, energy, and information from the environment, just like the cell medium. Mitra also noted the following points. Schrodinger's description that living systems drink orderliness and export heat to the sink, the S-shaped magnetic transition to the cooperative living state in Dyson's cell-first model. Now, the formation of a specific field-induced structure from amongst myriad alternative possible 3D patterns is analogous to that of an individual's DNA fingerprint chosen from myriad possible alternative sequences. It is like a subjective and conscious choice, and this inspired the field induction mechanism as a simple physical analog for consciousness. Next, a simpler analog code at the inanimate stage can smoothen the transition to the animate one with a complex digital code. He noted that the phase space, despite myriad components, is drastically reduced, and the fascinating world of soft matter. He noted the confluence of energy scales at the nanoscale of 4 different types of processes, including thermal ones. And of course, the all-pervasive role of fluctuations in biology with the fluctuation dissipation theorem as the modus operandi. And of course, we've already spoken about the environment responsive nature of the 4 billion year old tree of life. The main motivation for Mitra to look for H fields and spins was that an H field, not an E field, is directly linked to the property of rotation. You needed to address gyration, handedness, torque. In fact, from chirality to rotary motors, these phenomena are not comprehensible by pure vectorial processes. As Mitra repeatedly pointed out, time reversal symmetry is broken by the magnetic moment and H field, which are first-rank axial tensors. Meanwhile, Apurva Patel found that the genetic code numbers match the results of a quantum search algorithm. And Paul Davies wondered if quantum effects could even be relevant in a hot and wet prebiotic setting. In response, Mitra speculated on the potential of an H field to reverse environmental decoherence. Now, in the first paper, Can Magnetism-Assisted Quasi-Periodic Structures in Russell FES Bubbles Offer a Quantum Coherent Origin of Life? This paper, when it was posted on the archives, we soon heard from the new scientist. But some workers did not appreciate invoking magnetism and quantum phenomena in Origins of Life. However, we were glad that Michael Russell, Graham Karen Smith, Paul Davies, and some others welcomed it. To Mitra, all this seemed as signatures of two-way interactions between H fields and spins. In fact, Mitra made a connection between electron transfers in photosynthesis and the giant magnetoresistance effect, though at that time we did not have any data to support his conjecture. Then, a couple of years later, Professor Michael Russell sent us the work of Nauman's group, which clearly shows that the electron transmission probability through chiral biomolecular assemblies depends on the electron spin. And in fact, this maps well with spin polarized tunneling conduction through a field-induced magnetic dipolar network. What's more, spin polarized electrons in turn can generate chiral specific chemistry, as Rosenberg has shown. Now, since electrons need to be channeled to an organic carbon to create bioorganic compounds, if we imagine that these channels were magnetic networks, then transmission of spin polarized electrons could have caused the formation of chiral organics. And in this scenario, there is also scope of further entropic interaction driven phase transitions to modules like helices. So we speculated on such possibilities in the alkaline hydrothermal vent scenario. In fact, even today, spin selective electron transmission seems to be playing a role in the interactions of microbes with external electron accepting magnetic minerals. So to resume, the idea is that for patterns to compute, they must first resist thermal degradation. Here we try to mimic the state of quiescence, or let's say some state with minimal metabolic activity like that of repair and maintenance, so that with the passage of time, more complex means of sustenance in time could have led to Darwinian systems accreting information via natural selection. So this allows us to extrapolate computing boundary conditions not only to explain the tree of life with digital-like computation, but also to address its emergence using analog-like computation in the inanimate realm. Thank you so much.
Thank you very much for your wonderful presentation. Now, the house is open for audience interaction with Professor Gargi Mitra for 3 minutes.
Yes, I am Nimai Singh. So, when I was in Guwahati University as a head, I invited Professor Mitra. He gave a talk on the origin of human consciousness from physics point of view. The title may be slightly different. He worked with Gargi Mitra, no doubt. So, is it different from this work, or it is different? So, I want to ask about.
No, it's the same. In fact, I mentioned it. Nimai, if you go back to the slide, I don't know how to share the slide. If you go back to the slide where, oh dear, I don't know how to share a slide. I'll try.
Okay, anyway, thank you. I'll check you.
Yeah, if you just go back to the video and listen to it, you'll find that it is, in fact, we're talking about, the choice of one particular configuration as if, as a conscious choice from amongst alternatives. For sure. We would have been absolutely overwhelmed by your love. Where is... In fact, I don't know how to express my gratitude. Only my love to all of you.
Didi, how far up should I go in this?
I was hoping that I could find, no, I think this is not a good idea. It's easier for me to explain like this.
Okay.
Yeah, because so the idea essentially is that when you're talking about the field, the idea was about field induction as a mechanism. So it's the structure formation is happening from a myriad possible alternatives. And if you look at the analogy to DNA sequences, then a single individual has, it's almost like a conscious choice, one DNA fingerprint out of myriad possible sequence patterns. So it's like a conscious subjective choice. And there were some other aspects which I have. Actually, I think it's good to go back to the slides, but it has to do with also two levels, two separate levels with feedback between them.
But the consciousness paper actually has to do with the aspect of subjective conscious nature of the interaction. When it's a
Oh.
field-induced mechanism.
I'm afraid I have to
Thank you.
stop this very interesting discussion. We have to go on. I have just now heard from Alok that Robi Mahapatra, one of the distinguished alumnus of Delhi University, and also a student of Professor Mitra, is with us today. So I would like to request him to say a few words, if possible.
Actually, Professor Haridas, it seems that he is logged out. He was there during Professor Kaushal's presentation, and now he is logged out.
Oh, he is not there?
Yeah. He's logged
Okay.
out.
Are
Sorry.
there any more questions or comments on Professor Gargi Mitra's talk?
Yeah,
Otherwise, yeah.
yeah, can I ask?
Make it brief, please. Yeah.
Professor Haridas, can I ask a question?
Yes, you can.
Very-
Make it brief. Yeah.
Yeah. So, Dr. Gargi, I want to know there are two situations, conscious process and conscious observer. See, perhaps consciousness appears in two phases. Process is happening in conscious or observer is conscious. So there are two different situations, and which one you want to point out?
This is just a simple analog where you have a particular structure forming as a physical analog. It's only that. It's just a simple, we are not talking about maybe my father had other ideas, I don't know, but as far as the consciousness paper was concerned, it was just a simple physical analog that we were referring to.
Okay. So we bring this session to a conclusion now.